All right, this video is about measures of central tendency, specifically the mean, the median, and the mode of a set of data values. The mode of a data set is the value that occurs the most frequently. You can have no mode, which means that each item occurs once and only once, so no repetitions. We could have one mode, so just one value that occurs more frequently than all the others, or you could even have multiple modes where you have three or four, maybe even two values that occur the most frequent at the same uh, repetition level. So the median is the central value of an ordered distribution, which we like to sometimes say as the middle. To find it, we have to order our data from smallest to largest or least to greatest, however you want to think of that. If you have an odd number of data values, then you will have a median as the exact middle value. There'll be one value right in the middle of all the set. For an even number of data values, you're going to have actually two values that are towards the middle, and the median is actually the average between those two. So we have to add those two together and divide it by 2. So to find the middle, which means we're just looking for kind of what's the midpoint between the two middle values. The position of the median, so if you have a big list or a frequency table, I'll show you one of those in another video. To find the position of the median very quickly, you can take the number of items in your data set, which is n, plus 1 and divide it by 2. If that comes out to a whole answer like 5 or 6, that means your median came from an odd set of data, and it'll be one value in the middle. If you get like a 7.5 for this value when you do n plus 1 divided by 2, that actually means you have an even set of data, and you have to find the middle between the 7th and 8th positions because you got a 7.5. So remember, n is the number of total data values. The mean is found by summing all of your entries and dividing by the number of entries. That's kind of what we think of as an average. The ways we write that, we do have actual notation for the mean. If you're doing statistics, or finding statistics, I should say, which means you're dealing with a sample set of data, we call that X bar for the mean, and it's the sum of all your X's divided by the total number of items in your data set. If you have your entire population, that means you have all of the data for the entire population. You're not taking a smaller sample. We call that mean mu. It's this Greek letter, and it's the sum of all the x's still, but divided by the total of the population. So the big N stands for population, number of items or objects, whereas little n just means the size of the sample. Okay. Now, just some things to note. The median is a more resistant value, but not sensitive to the size of the data value. So median is not going to get changed by having a very high value or a very low value in your set. It's because it's the middle. It's not really affected by all of the outer edge values. The only thing that could change your median would be if you added more elements to your set or took away elements, okay? And that could possibly shift where your median is. The mean is less resistant because it is influenced by very high and very low data values. Because we sum all of the values in our data set up to get the mean, having a very, very large or very, very low data value is going to make, when we do this division, it's going to adjust that mean and move it maybe towards the right or towards the left of our actual central tendency. A trimmed mean can sometimes help with that. It's where we take off an equal percentage of high and low values from our data set to get rid of some of those extreme values and get a more centralized mean. So I'll show you how to do a trimmed mean. And you can do different percentages of that. The most typical one that we will do is a 5%, maybe a 10%, but most likely you see 5% trim means. And then a weighted average can be found by taking the sum of all your x's times their weights, where x is a data value and w is the weight assigned to that data value, and dividing that by the sum of all the weights. So a lot of times this is in like a classroom setting where you have tests worth a certain percentage, homework are worth a certain percentage. All those percents actually add up to 100%. So we put them in decimal form. We would say my average of all my tests times the 30% as a decimal. So 0.3 plus the average of all of my homework times, maybe that's worth 10%, so times 0.10. You do that for all your categories, and then you notice that the percentages add up to 100%. So we're actually dividing by 1. So a lot of times you don't actually write the sum of the W in the bottom of your formula if you're doing it with percentages. We did sometimes talk about how like you could do GPA this way, and in that way, the sum of the W's would be the sum of your total credits. So sometimes you do have something to divide by. It just depends on if they've given you the information in percent form or not. So let's first look at just doing a basic mean, median, and mode, and then a trimmed mean, and then we'll look at an example of a weighted average. So the following data is the number of hours rounded to the nearest tenth that students spent studying for their statistics midterm. So again, this was, I did this one in the stem and leaf video. So we've got all of this data. If you're going to find the mean, median, and mode, the best thing to do is start with reordering your data. So I'm going to I have a blank chart here. I'm going to list these from least to greatest and mark them off as I go. So the lowest value in this set is 8.6. I'm going to mark that off. Then the next highest value is a 9.1. Then I believe we have 10.1. We don't have a 10.2. We have a 10.5. We have 10.8. We have no 11.0, but we do have 11.1, not once, but twice. We have 11.2. We have an 11.3. The only other 11 I see is an 11.9. We don't have 12.0, 12.1, but we do have quite a few 12.2. So 12.2, 12.2, 12.2. We have a 12.3. And the last 12 value is a 12.5. For 13s, we have a 13.1. We have two 13.3s. We have a 13.9. And our highest value and last value is a 14.0. So that's always helpful when you're doing your mean, median, and mode, is to go ahead and list everything from least to greatest. That'll help you find the median. Of course, you need it for the median. It's required for that, but it actually helps you see the mode as well. So the mode is actually the one that occurs the most. So we have a couple of repetitions, but we'll have two 11.1s, two 13.3s, but the most frequent is that we had three 12.2s. So this is a single mode because it's the most frequent, and it is a 12.2. It occurred 3 times. That was the most repetitions in our list. Then we want to find the median. Well, notice we have 20 total data items because this was 2 rows and it's 10 items long. So since we have 20 items, you can find the position of your median, or we have a shortcut formula for that. This is 20 plus 1 divided by 2. So that's 21 divided by 2. That's going to be 10.5. That is not the actual value of the median. That means that we're between the 10th and 11th position. Okay, so that makes sense because we have an even set of data that our median is going to be an average of the 2 middle values. So in fact, your median is right actually here. It's whatever's between 11.9 and 12.2 because that would be the splitting point between the 10th position and the 11th position. So we're going to find that by taking those 2 values and adding them together and finding, you can either think of it as an average or the midpoint. Both things in this regard are the same formula. So it's 11.9, since we're just going for the middle between 2 consecutive numbers, plus 12.2 divided by 2. My median is 12.05. So notice my mode is not exactly the same as my median, but they're close. They're close to the same value. And that doesn't always happen. It depends on if your data has a peak as the center of all the data or not. Now let's look at the mean. So this is a sample of data. So we're going to add up all of these values. Now on your calculator, you would normally type these in. So I'm just going to dot plus all the way to 14. We know we're going to be dividing that by 20. So let's take our calculator. We have 8.6 plus 9.1 plus 10.1 plus 10.5 plus 10.8 plus 11.1 You could times it by 2 since there's 2 of them, or you can just add it twice. That's up to you. Plus 11.2 plus 11.3 plus the 11.9. That's our first row. Then we have 12.2 plus 12.2 plus 12.2. We had 3 of those. We have a 12.3. We have a 12.5. It's really easy to skip one if you're not paying attention. We have a 13.1. We had 2 13.3s. We have a 13.9 and a 14. Okay, so that's my total on top. So that's 234.7. We're dividing that by the 20. And notice that comes out to equal to 11 point, now I didn't give you any rounding directions, so we're going to just write the whole thing, 375. Okay, so notice that that is smaller than the median. That is because we kind of have a super small slight skew to the left. We looked at that when we did the stem and leaf plot for this specific set of data. Now, if we want to write these answers here, so let's make sure we write them down. Then we can do the trimmed mean of this group. So we had a 12.2, 12.05, and 11.735. Now let's find a 5% trimmed mean. Okay, so how do you find a trimmed mean? Well, you take the percentage we're wanting to cut off, which is as a decimal would be 0.05. You times it by the number of items in your data set. And that is the amount we're going to actually knock off the bottom of our list and the top. And we round this to the nearest integer. So this actually came out to a nice integer. So it's 1. So we're going to remove the 1 lowest value from our list and the 1 highest value. So technically, you're actually trimming off 5% off the bottom and off the top. You're doing an equal trimming. So technically, even though it's a 5% trim mean, that's 5% off of each end. So you're really finding kind of the mean of the 90% that was in the middle. So that's a little tricky on how they word that. So I'm just going to go back up here and we're going to mark off 8.6 and 14. Now, instead of re-adding all these together, I can just subtract those two from my total that I had. So the 234.7, this was the total of all 20 items. And we're going to subtract off, it was the 8.6 and the 14.0 because we're taking off the highest and the lowest. And then we'll redivide by the new number of items in our list, which is 18 now. So 234.7 minus 8.6 minus 14, that is 212.1 divided by 18. And that gives me 11.783 repeating. So I'm going to round that to 3 decimal places like this. So 11.783. So notice it did not make it match the median exactly, but we are closer to the median. This was being pulled down a little bit too much by that 8.6 value. You can tell that we were more weighted towards the lower or left side skewed because this was lower than the median. And we're getting higher by removing a low and a high value. Now, you might want to consider in a situation like this, actually doing a 10% trimmed mean, which really means you're removing 20% of your data. So depending on how big your data set is, that may or may not be something that someone would want to do. So that's just something to be considered when you are looking at the data. All right, so our last example is of a weighted average system. So Julia is taking Math 100 and the class has a weighted average system for final grades. The class is weighted 30% for the midterm, 30% for the final exam, 10% for homework, 15% for quizzes, and 15% for the projects. Her current category averages, this is probably right at the end of the semester, are 58 on the midterm, 72 on the final exam, 98 on homework, 80 on quizzes, and 70 on the projects. What grade will Julia get in the class? Okay, so remember this is our weighted average formula. Sum of all the x's times their weights divided by the sum of the weights. So we take the category averages for each group. So 58 on the midterm, we times it by the percent as a decimal for the midterm weight, which would be 30, plus we had a 72 on the final exam, which is also weighted at 30%, so times the 0.30. Homework had a pretty good average there, 98, but that's only weighted at 10%, so times 0.10. The quizzes had an 80 average on those, and that's weighted at 15%. And then the projects, 70 average overall on those, and they were weighted at 15%. Now, if you add all those decimal weights together, it actually equals to 1 or 100%. So some people put the divide by 1, sometimes people don't. As long as this is adding up to 100%, it can go either way on that. If it didn't add up to 100% for the weights, we absolutely would need to be dividing by whatever our weights added up to, which is kind of an interesting topic. That's how you can figure out your current grade in the class. You have to only use the categories that are currently being used. So if you haven't taken your final yet, you wouldn't have a 30% in there for it because it's not been taken. So your weights would have actually added up to 70% at that point, so 0.7. So that's kind of how gradebooks online calculate your grades, even though you haven't taken everything yet. So we do 58 times the 0.3 plus 72 times the 0.3 plus 98 times the 0.1 plus the 80 times the 0.15 plus the 70 times the 0.15. And so it looks like that Julia would get a 71.3 in the class, which is a C. All right, I hope this video was helpful.